Welcome to today's Explainer. We're jumping straight into the action today with Chapter 7, Linear Inequalities. Now, I know what you might be thinking. Oh, great, more abstract math. But I really want you to shift your perspective for a second. We aren't just looking at boring textbook math today. We are literally learning a secret language. Think of it as a mathematical code designed to help you decode the real world. Because, let's be real, things in life are rarely perfectly equal. Most of the time, we're dealing with budgets, speed limits, minimum requirements, maximum capacities. That is exactly where inequalities come in, and by the end of this explainer, you're going to be completely fluent in this language. Here's a quick look at our roadmap for today. We'll be hitting 1, the code, 2, the ground rules, 3, the big twist, 4, real-world translation, 5, mastery challenge, and finally, 6, the cheat sheet. All right, let's kick things off with Section 1, the code, learning the language of inequalities. You know, we spend so much time in algebra absolutely obsessing over the equals sign. But what happens mathematically when two quantities just aren't perfectly equal to one another? Well, that brings us right to our foundational definition. An inequality is simply the relationship between two quantities that do not have the same value. It's basically an expression that tells us about the relative size of values. So instead of saying A exactly equals B, an inequality lets us confidently state that A is larger, smaller, or at a specific limit compared to B. It's all about comparing those relative sizes. To actually write these relationships out, we used 4 foundational symbols. First up, we've got the greater than symbol. For example, 4 squared is greater than 9. Since 4 squared is 16 and 16 is bigger than 9, that checks out perfectly. Next, we have the less than symbol. For instance, -5/6 is less than 4. Any negative number is going to be less than a positive one, so that makes total sense. Finally, we have the greater than or equal to and less than or equal to symbols. These look almost identical to the first two, but they have that little solid line underneath. All that means is the two sides could also exactly match. Think of these 4 symbols as the core vocabulary of our new secret language. Moving right along to Section 2, the ground rules, properties of inequalities. Okay, so now that we have our vocabulary down, how do these symbols actually interact? Let's establish the ground rules. The first rule is called the converse property of inequality. It sounds super fancy, but honestly, it's incredibly intuitive. If A is greater than B, then it naturally follows that B is less than A. Think of it like a simple age analogy. If Lily is older than Alice, then Alice simply must be younger than Lily, right? So the crucial takeaway here is, if you flip the subjects on the left and right sides of your equation, you absolutely must flip the direction of the symbol between them. Next up, we have the transitive property. Basically, this rule tells us that when we link up inequalities in a logical order, we can just jump right over the middleman. If A is greater than B and B is greater than C, then A is automatically greater than C. Returning to our friends, if Lily is older than Alice and Alice is older than Daisy, then we can confidently say, without a doubt, that Lily is older than Daisy. We completely bypassed Alice to connect the first and last values. Easy, right? All right, brace yourselves for Section 3, the big twist, the symbol reversal rule. So we've got the basics down, but now we arrive at the drama, the absolute biggest trap in Chapter 7. Listen, when you add or subtract, the symbol stays exactly the same. When you multiply or divide by a positive number, again, the symbol stays the same. But there is one massive exception. What happens to our carefully balanced inequality when we introduce multiplication or division by a negative number? Welcome to the danger zone. This right here is the absolute golden rule of inequalities. If you multiply or divide both sides by a negative number, the direction of the inequality symbol must be reversed. It flips entirely. And hey, this also applies to what we call the additive inverse, like multiplying both sides by -1, and the multiplicative inverse, which is when you flip the fractions on both sides to find their reciprocal. Literally, anytime you apply these specific negative or reciprocal transformations, you have to flip that sign. No exceptions. And this perfectly shows exactly why we have to do this. Just look at the left side. 3 is clearly less than 7. We can all agree on that. But if we multiply both sides by -1, we get -3 and -7. If we just kept the less than symbol as it was, we'd be standing there saying -3 is less than -7, which is completely mathematically false. Think about a thermometer. -3 is warmer, it's higher up on the number line. So changing the +3 and 7 to negatives absolutely forces the less than sign to flip into a greater than sign. -3 is greater than -7. Let's see this in action with Section 4, Real-World Translation. Inequalities in Daily Life. Let's shift gears from abstract algebra to some actual daily situations right here in Malaysia to prove why this math really matters. Take Mr. Mohan, a local businessman. He plans to donate 3% of his monthly business profit to a local charity. Awesome, right? But he has a specific goal. He wants his donation to strictly exceed 240 ringgit per month. We can translate this directly into our math code. 3% of his profit, let's call it P, is 3 over 100 times P. Since it needs to strictly exceed 240, we use the greater than symbol. So the inequality becomes 3 over 100p is greater than 240. Boom. Just like that, a real-world business goal becomes a totally solvable algebraic expression.
Honestly, the world is absolutely full of these hidden inequalities. Just look at these everyday phrases. Fatima earns overtime if she works at least 9 hours. At least translates to greater than or equal to, so T is greater than or equal to 9. The time to make a casing is less than 42 days. That's a strict less than symbol. In a fishing competition, the fish must be at least 32 centimeters to qualify. Again, greater than or equal to. Or take Madam Chen, who gives each neighbor not more than 0.2 of a kilogram of cake. Not more than means it could be exactly that amount or less, so we use the less than or equal to symbol. Once you actually know the code, you start seeing it literally everywhere.
Time to put it all together. Section 5, Mastery Challenge. Solving inequalities step by step. All right, let's enter the mastery phase and put our rules, and especially that big twist, to the test. Let's walk through this one step by step. In step 1, we start with the inequality negative x over 3 is less than 9. Obviously, our goal is to isolate x. To do that in step 2, we need to multiply both sides by negative 3. But wait, alarm bells should be ringing right about now. We are multiplying by a negative number. That means in step 3, our golden rule kicks in. We must reverse the symbol. The less than sign flips to a greater than sign, giving us our final correct answer, x is greater than negative 27. I'm telling you, if you forget to flip that sign, the entire answer is wrong, so always stay on high alert for negatives. Now, let's level up to simultaneous inequalities. This just means 2 rules have to be true at the exact same time. The trick here? You handle this by solving them completely separately first. In step 1, we solve the first inequality. 2x plus 5 is less than 11. Through some basic algebra, we get x is less than 3. Then, in step 2, we solve the second inequality. 3x minus 10 is less than 5, which gives us x is less than 5. Now for the magic in step 3. We imagine both of these results on a number line to find their common region, basically the area where they overlap. If a number has to be less than 5 and it also has to be less than 3, the overlapping truth is just everything less than 3. So our final combined solution is simply x is less than 3. We made it! Let's wrap things up with Section 6, the cheat sheet, key takeaways and exam tips. We have covered a lot of ground today, so let's lock this in with a perfect screenshot-worthy recap for your exam prep. First, remember that inequalities are simply comparing relative sizes using our 4 main symbols. Second, rely on your converse and transitive properties to logically link and arrange those values. Third, and I seriously cannot emphasize this enough, it is absolutely critical that you reverse the symbol whenever you multiply or divide by a negative number. Write that on your hand if you have to. Finally, when you're dealing with simultaneous inequalities, solve them separately first, and then find where their truths overlap on a number line. I want to leave you with this final thought. Math isn't just some abstract concept trapped in your textbook. So, the next time you are out shopping, or maybe setting a budget, and you hear everyday words like at least, exceeds, or not more than, ask yourself, what hidden mathematical code are you actually seeing? Because now you have the exact tools to translate and solve it. Thanks so much for joining me on this explainer. Keep decoding the amazing world around you, and I'll catch you next time.